7-3 is all about the number e. Alec, will you move back, please? Thank you. Okay, now e does not be a variable where it can stand for any number. E stands for a particular number, and it stands for this number, 1 plus 1 over n to the n, as n increases up to infinity. Okay, this is a mathematical number that comes up often and is used probably most commonly in algebra, at least, for an interest formula. You do not need to worry about memorizing this formula. This formula will not show up anywhere. I won't ask you what the formula is for E, but we do need to use this in order to figure out what that number actually is. So take your calculator out. Okay, and plug that into your y equals. Okay, we want to know what happens as x gets really large. So what I'm going to do is go to my table setup. And I'm going to change this to ask because I want to tell my calculator what to put into the table instead of it just giving me numbers. So I'm going to change it to ask. And then I'm going to go back to my table, and it'll be blank because it's waiting for me to tell it what numbers to put in. So let's just start with 1. What happens if I put in 1? Well, then that formula is going to give me 2. What happens, we want n, this number n, or x, in their calculator's case, to get really large. So I'm going to go with 10 and 100. And 1,000. Okay, and if we keep going up with really large numbers, we're going to get really close to this value e. Okay. It doesn't matter what your table starts at. The idea is that you're supposed to see that these y values are approaching a certain number, and what they're approaching is this number or really close to that number right there, 2.718. If you remember that, that's basically what e is. Your calculator does have a button for e. Actually, it has 2 of them. Right here above the division sign, if you go second division, whoops, I need to get out of here, sorry. If I go second, and then that division sign, it gives me an e. And that is actually the value of e rounded off, because your calculator can't give you all of the decimals. It's an irrational number. Or if you have e to an exponent, that one's over here, on the ln. So second ln gives you e. If I want e to the first power, it'll give you the same number. Okay, here's our book's definition. You don't need to write this whole thing down. What you need to write down is what your calculator is telling you, is that that's the value for e. The other thing that's important to note here is that this is irrational. So I'm kind of glad that you said repeated, because it's not repeated. If it were repeated, it would be rational, meaning that it could be written as a fraction, and this one can't. The main part of this section is just going to be to simplify. Guys, the main part of this section is going to be to simplify exponential expressions like this one. And basically, you're going to treat it the same way that you would if e was a variable. So if that was x squared times x to the 5th, what would it be? E to the 7th, or x to the 7th. That's the idea. So you guys go ahead and try to simplify those. Okay, the first one we can simplify our numbers. 12 over 3 is 4. We can cancel 3 of our e's out, so we're left with e to the first on the top. And you don't need to have the 1 for your exponent. The second one, I hear lots of mistakes out there. So 5 squared e to the negative 6x. Does the 5 have a negative exponent on it? No, so then that doesn't move. The only part that moves is this e, and that's going to move down to the bottom. So 25 on top, e to the positive 6x on the bottom. Okay, who has questions? We are going to do a graphing one on our notes. There aren't any that you actually have to graph on your homework, except for I think there might be a couple matching, where you have to decide which one matches up. There are just a few things that I want you to know about graphing. First of all, this formula right here, this is something else that you will not need to memorize. Okay, but write it down because you are going to need it for your homework. Rx, yep. This one's called a natural base. E is the natural base. Okay, just like before, we can tell if it's growth or decay based on, in this case, A and R, since there's not a B in our equation. If A is greater than 0 and R is greater than 0, it's going to be growth. If A is greater than 0 and R is negative, it's going to be decay. Okay, hopefully you're wondering why. If R is positive, it's growth, and negative, it's decay. So this part of the equation right there, the e to the r, that's just a number. E is that 2.718 number. If r is greater than 0, like 1, that's our b value. Okay, a times b to the x. B is greater than 1 in this case, which makes it grow. If that r value is less than 0, like negative 1, remember what that negative exponent does. It makes it into a fraction. Okay, now that number, that fraction, is in between 0 and 1, which makes it exponential decay. You don't need to put these down on your notes unless you want to. It's up to you. They are in the book. Here's your basic functions, e to the x and e to the negative x, this one being the growth and that one being the decay. Anyone have questions about these? Okay, so we are going to graph one using our calculator. The important part is more that you know how to put it into the calculator than anything else. So grab your calculator out. Okay, and the first thing that you need to know is where that E button is with the exponent. So you can either use the one above the division sign, but even better would be the one above the ln, so that you already have that exponent. And it gives you a parenthesis as well. When you plug this in, this whole thing needs to be in parentheses as well as the x plus 2, or x minus 2. So you're going to have 2 sets of parentheses in there. Make sure when you're putting this in your calculator that you close both sets of parentheses. If you only close one set of parentheses, it's going to include that plus 1 as part of the exponent. We don't want that to be part of the exponent. Go back to your standard Zoom. And if you were to graph this, all I'm really looking for are those 2 points again. And you can easily use your table to find those. Make sure you change your table set back to auto. And you can graph 0, 12.1, 1, 5.75. It should look like that as long as you have a standard window. I can come take a look at yours in a second. Okay, so then the last question is domain and range. Without even looking at the graph, we should be able to tell what both of these are. What's the domain? All reals. What's the range? Greater than 1, because this is a shift up 1. So instead of the x-axis, y would be greater than 1. Dakota? Okay. Any questions? Okay, last thing. Another interest formula for you. This is one that's commonly used. This is a good one to know. PERT. Remember it as PERT. A, the amount, is equal to the principal times E. It's always E to the RT. R being rate, T being time. Notice that this one's compounded continuously. The interest formula that we had from 7.1 would be compounded monthly or daily or quarterly. This one's different. It's compounded all of the time. So if we were trying to figure out what our balance would be, our amount would be $4,000 for our principal times E to the rate. What would the rate be? 0.06. And then after 1 year, so times 1. Now, the 1 isn't going to have any effect on it in this case. But let's say it was something other than 1. It was 2 years or 3 years. We'd have to make sure we put that in parentheses. You guys figure it out. Make sure you round.